This is our final exam study guide. We're picking up on number 39. This is part 4. Number 39 says write the polynomial in standard form, then name it based on its degree and based on its number of terms. In standard form, when you're talking about polynomials, unlike ax plus by equals c, in this one, when you're talking about quadratics or anything that has the same variable represented more than once, just with different exponents, you want the exponents to decrease. So whatever your biggest exponent you want it to come first, followed by the next largest, and so on. The last one will be your constant term. We have two like terms right here. We have negative 11x squared and positive 6x squared. We can combine those. Negative 11x squared and positive 6x squared is negative 5x squared. Then what we want to do is we want to put the next variable term next. So we only have one more variable term, negative 8x, so let's let that one come next. Negative 8x, followed by our positive 2, which is our constant term. So this is written in standard form because your exponents are decreasing. 2, then 1, then no more x's. So it says that after it's in standard form, name it based on its degree. Degree is the value of the highest monomial exponent. This is a trinomial, and we'll get to that actually in just a second. Kind of jumped ahead for a second. But there's 3 parts, 1, 2, 3 of it. In this monomial, it's the biggest one is 2. So since it's 2, that is called a quadratic. Don't let that confuse you. Quadratic. Quad, normally that term quad refers to 4. But when you're talking about something being squared, think of a square having 4 sides. Quadratic. And it says, and name it based on its number of terms. We actually did that one a second ago by accident. There's 1, 2, there are 3 terms. So we call it a quadratic that's the prefix for 3, trinomial. And nomial just means number. So a quadratic 3 number, quadratic trinomial. And this is your answer, quadratic trinomial. This is it written in standard form. It asks you first to write it in standard form, then to name it. 40 is actually a step back from 39. This is you only doing the first part of 39. It says write it in standard form. So make it count down. Make the exponents count down. You want the largest exponent to go first. In this case, the third power. Negative g to the third power would be first, followed by g to the second power, which is plus 3g squared, followed by g to the first power, which is positive 4g, and we know it's positive because there's nothing in front of that. That's why it's plus, followed by the constant term, minus 2. Notice your exponents count down, 3, 2, and then 1 that's not shown. This is it in standard form. Just count them down. So if you would name this like 39, if you would name it based on its degree would start with a 3. That would be cubic. It would be cubic. The other one was quadratic. This one's cubic, 3. And this has 4 terms, so we would just call it a cubic polynomial. Anything over 3, we just simply call them polynomials. But this is all you had to do for 40. Now this is finding the degree of the monomial. Even though it looks like there's more than one term up there, there aren't. Since all 3 of those things are multiplying by each other, this is a monomial. There's only one term up there. So 7m to the 6th, n to the 5th, you actually add 6 plus 5 together, and the degree of 41 is 11. You add 6 plus 5. You add them together. Same thing with this one, 8 plus 5, and your degree is 13. Anytime you see degree of monomials, 11 and 13 in this case. Again, if you look back at 40, the degree of 40 would be 3, because out of these monomials, there's 1, 2, 3. There's 4 terms up here. That's why you don't add up 3 plus 2 plus 1. This one would just be 3. This is 11 and 13. Number 43, the description says match the expression. And when you have a multiple choice part in a couple days, there'll be something to match. But just rename it as just name the expression. Okay, you name it 2 ways. You name it based on its degree, and its degree is the highest exponent. Its highest exponent is 3, so its degree would be called cubic, because 3 means cubic, and then you also name it by its number of terms. And its number of terms, there's 1, 2, 3 of them. So it is a cubic again, there's because there's 3 of them, nomial. So your answer would be cubic trinomial. Uh, 44 is actually missing something. It says write the perimeter of the figure. If you just wrote it out, we know that the perimeter of figures are this plus this plus this. So if we have the value of the first one, it would be 3x plus 2. And the value of the second one, 6x. And the value of the other one is 5x. Again, there's no 1, 2, or 3 there. That's just the way I wrote them. I just went clockwise. You would add 3x plus 2 plus 6x plus 5x. And that would give you the perimeter. But we don't know what the perimeter is. So we'll just say equals the perimeter. All we can do at this point is just combine our like terms. 3x plus 6x is 9x plus 5x is 14x plus 2 would be equal to your perimeter. That's really all we can do for that problem, since there's no other information available to us. '45, we're simplifying the difference of these. Since they're difference, that means they have minus in the middle of them. So you want to do what's opposite of this everything in the second one. So you have, you want to do your same terms or your like terms. You want to combine them. The first one will go with your highest exponent. So negative 5x to the fourth. It says minus negative 7x to the fourth. Remember, minus a negative means plus. So negative 5 plus 7 is 2x to the fourth. Then you want to go with your next highest exponent value. The only one we have is x to the first power. So negative 7x minus negative 9x. Remember, minus a negative means plus 9x plus 2x. And then the last one, positive 5 minus negative 5. Minus the negative again means plus. So 5 plus 5 is a positive 10. 2x to the fourth plus 2x plus 10. Do the same thing with the next one. Your highest exponent value is 4w squared minus 2w squared. 4 minus 2 is 2w squared. Your next highest exponent is negative 4w to the first minus 3w. So negative 4 minus 3w will be negative 7w. And then your last one is negative 8 minus negative 6. Minus the negative again means plus 6. So negative 8 plus 6 is minus 2. Those are the types of problems, even when you start understanding this stuff back and forth, trip you up a little bit. So make sure you pay extra attention to those kind of problems, because you'll lose a negative when you're trying to do it, since there's so many terms up there. 47 says simplify the sum. These are a little bit easier because it's just addition instead of subtraction. Again, start with your highest exponent, 4u to the third plus 6u to the third. 4 plus 6 is 10u to the third. Notice u to the third didn't change. It stays just like it is. 4u squared plus, there's no squared over there, so it's just plus 4u squared. We'll leave it just like it is. Notice there's no u to the first power in the first one, so we'll just bring that one down just like it is, minus 2u. The reason we couldn't take it away from 4u squared is because one of them is u to the first, one of them is u to the second. Then the last one we'll do, 2 plus 8 is positive 10. Notice it's written in standard form, the third, then the second, then the first power plus 10. And again, this is the type of problem that'll mess you up, because you'll lose something in it since there's so many different terms up there. Then we're simplifying the product for these. Now we're multiplying. So you multiply what's not the variable, so 2 times it'd be 1 in this case, so it'd just be 2 to the n plus 1 plus 2. the n to the 1 plus 2. That would give us 2n to the third. Do the same thing. Distribute 2n. We did it to that one. Do it to 3n. So 2 times 3 is positive 6. N to the 1 plus 1. N to the 1 plus 1 is n squared. And then 2n times 4 is plus 8n. So 2n to the third plus 6n squared plus 8n. Do the same thing with the next one. Give 3p to the fourth times 4p to the fourth. 3 times 4 is 12. P to the fourth means p to the 4 plus 4, which is p to the eighth. 3p to the fourth times 7p third. 3 times 7 is plus 21. P to the fourth plus 3 is p to the seventh. 3p to the fourth times 4p. Again, 3 times 4 is plus 12. P to the fourth plus 1 is p to the fifth. And then the last one, 3p to the fourth times 1 is plus 3p to the fourth. Again, a lot of terms up there, a lot of exponents shown. Make sure you don't lose them. 50 says 8x squared times 4x squared. 8x squared times 4x squared. 8 times 4 is 32. X squared times x squared means x to the 2 plus 2, which is x to the fourth. And 8x squared times 4y to the sixth. 8 times 4 is plus 24. X squared, I'm going to have to move this one over. X squared, X squared y to the sixth. Notice we didn't add x and y up because they're not the same bases. This is all we can do with this one. 32 x to the fourth plus 24x squared y to the sixth power. We're still multiplying on 51. Just multiply 7a to the third times 5a to the sixth. 7 times 5 is 35. A to the third plus 6 becomes a to the ninth. And 7a to the third times negative 2b to the third. 7 times negative 2 is negative 14. Notice they're not the same base as a and b now. So you just simply write a to the third, b to the third. And that's all we can do. 5a squared times 3a to the fourth plus 3b. 5a squared times 3a to the fourth. 5 times 3 is 15. A squared times a to the fourth becomes a to the 2 plus 4, which is 15a to the sixth. And 5a times 3b. 5 times 3 is plus 15. A squared b. Again, you don't add a and b's exponents because they're not the same base. Do the same thing with 8p. 8p times negative 3p squared. 8 times negative 3 is negative 24. P to the 1 plus 2 becomes p to the third. 8p times 6p. 8 times 6 is plus 48. P to the 1 plus 1 becomes p squared. And 8p times negative 2 is negative 16p. A lot of terms up there. Then we start foiling 3x minus 7 times 3x minus 5. Our first thing tells us, F tells us to do the first terms. 3x times 3x. 3 times 3 is 9. X to the 1 plus 1 is x squared. The next one, O, tells us to do the outer terms. 3x times negative 5, the things that are on the outsides. 3 times negative 5 is negative 15x. The next one tells us to do the inner terms, I. So the things that are closest to each other. Negative 7 times 3x. Negative 7 times 3 is negative 21x. And then finally, L tells us to do the last terms. Negative 7 times negative 5. Negative times a negative is a positive 35. Not quite done because you have like terms in the middle. Negative 15x and negative 21x. We can combine those. They both have x to the first power, so we'll leave it as x to the first power. Negative 15 minus 21 is negative 36. So you have negative 36x, bring everything else down, 9x squared, and plus 35. Foil out the second one. Your first term's F, 4x times 2x is 8x squared. Your outer terms, 4x times 5 is plus 20x. Your inner terms, 3 times 2x is plus 6x. and your last terms 3 times 5 is plus 15. You can combine, again, you can combine what's inside the middle, just like we did on the last one. 20x plus 6x is 26x. Bring everything else down. 8x squared, it was a positive 26, so plus, and positive or plus 15. 25 says simplify using the distributive property. The distributive property, since you're talking about two binomials, actually is just FOILing still. So don't let that, if you see distributive property, don't let that fool you. Just FOIL it like you've been doing. Your first two terms, 5h times 5h. 5 times 5 is 25h squared. Your outer terms, 5h times negative 6 is minus 30h. Your inner terms, negative 5 times 5h is negative 25h. And your last terms, negative 5 times negative 6 is plus 30. Combine your like terms, 25h squared. These will be the like terms. Negative 30 minus 25 is negative 55h plus 30.